morning, my dear students. So today we are going to continue the chapter number 2, number systems. The last class we are discussed the informations regarding about different types of number systems, right? So what are the different types of number system? We have options. So totally 4 different types of number systems. Okay. So number 1, that is the very basic binary, and number 2 decimal, number 3 octal, and number 4 hexadecimal. So these are the 4 different types of number systems we have. At the very first, we are going to see about decimal number system. So what is decimal number system? Why we are going to start from decimal number system? Why? Because our decimal number system is a very most popular number system in our daily life or day-to-day life, because it is the oldest and most popular number system we have to use in our daily life. It consists of how many digits? Totally 10 digits. Okay. So decimal number system having how many digits? 10 digits. Right from 0 ends with 9. Totally 10 different digits. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so totally 10 digits. Okay. Then this number system, the decimal digit is weighted relative based on the position in the numbers. Okay. So how we are going to identify the position of the numbers? The weightage of the particular value. Okay. That is called as positional number system. Okay. We can call that is what? Positional number system. Okay. So now we are going to see about the example of this decimal number system. Okay. So how the decimal number system should be working and how it should be framed in the numbers. Okay, we'll see the example. So this is the example of decimal number system. See the example. The number is 123. This is a number. So this is a decimal number. How I am saying this is a decimal number? Because the numbers are framed between 0 to 9. Is this correct? Yes. That is what? 1, 2, 3. That is 123. So these digits are included in the form of 0 to 9. Yes. And also the another identification is this, whether it is decimal or not. How can you identify? Means the base value. This is the base value. So base value is what? 10. So once the number having the base value is 10 in the sense, that number should be called as decimal number. Okay. Students, please remind this. Once the given number having the base value is 10 means that is what number? Decimal number. So this is obviously this is what? Decimal number. So this decimal number, how we should be framing? Now we are going to discuss. So see that you just write 123 simply, and you have to divide it by the number or splitting the number, just simple. Number 1, here 2, and this is what? 3. So totally this is what? 123. You just split the number, and you have to start from the right side of the digits. So in this 123, the right side digit is start from number 3. So that should be alerted. The position value is 0th position. Okay. So this is what position? 0th position in the decimal number. So that's why I am putting the value 10 power 0. Understood? So 10 power 0, why I am telling like that? This is the starting, that is, this is the 0th position. So, and this is the decimal number. So that's why I am putting the value 10 power 0. The position value we can mention in the power on the particular number system like that. So that's why I am putting 10 power 0. So 3 into 10 power 0. Just I write this plus the next number is what? 2. So that 2 number is alerted by 2 into 10 to the power of 1. So first position is 0 means the next position is what? 1. And obviously the next position is what? 2. And in case we have one more number in the sense the next position is what? 3, like that. So 10 power 0, 10 power 1, right? Now 10 power 1, this is the first position. and the value is represented by 2 into 10 power 1 plus the next value number is what? 1. 1 into 10 to the power of 2. This is the next position. So right from 0, 1 and 2 like that. This 0, 1, 2 is a positional number system. That position you can mention on the top of the particular number system, like now a decimal or whatever it is. So 10 power 0, 10 power 1, 10 power 2 like that. Now you just simplify it. 10 power 0. So what is that? Anything power 0, that is what? 1. So 10 power 0 is 1. So 3 into 1 I just write. Plus 10 power 1 is nothing but what? 10. Right? So now 2 into 10 plus 10 power 2, that is what? 10 square. We can call as 10 square. That means 100. So 1 into 100 like that. Okay. So the left hand side value always same. The right hand side only I can simplify it. The next step, again we are going to simplify. 3 into 1, that is 3. 2 into 10, that is 20. 1 into 100, that is what? 100. So now finally you just add all the values. 100 plus 20 plus 3. Totally 123. Then finally put the base value is what? 10. So students, now you are understood how the decimal numbers systems are working and how the values and position numbers are allotted in the particular number series. Now you have to understand well, I hope, right? So this is a sample of decimal number system. So once again I repeat the theory part. So it consists of digits 0 to 9, totally 10 digits. Yes, correct. And point number 2, it is the oldest and most popular number system used in our day-to-day life. Yes. Number 3, in the positional number system, each decimal digit is weighted relative to its position in the number. This thing only I showed in the previous slide. Yes, 10 power 0, 10 power 1, 10 power 2. So that is what positional number system. Then next point, this means that each digit in the number is multiplied by 10. Why? Because this is what? Decimal number system. The base value is 10. So that's why we are putting 10 and multiply it. Okay, to the power corresponding to that digit position. So what position value we have? That position value multiplied with 10. Got it? So this is the way you can create and understand the decimal number system. And this is the example already I explained, right? That's all. The next number system, binary. This is the second number system. This is what? Binary. So already I told binary means what? Two values. So this binary number system having only the two possible values. One is 0, another one is what? 1. Okay, so there are only two digits in the binary system, namely 0s and 1. And the next, this binary number system, the base value is what? 2. Understood? So you can multiply the positional numbers with the powers of 2. Got it? 2 power 0, 2 power 1, 2 power 2, like that. Okay, right. And especially this number system, we have a two different positional weight. Okay, so one is most significant bit, that is what? MSB, and then another one is least significant bit, that is what? LSB. There are two different positional weight is there. Okay, so this positional weight we have a two different option. One is MSB, another one is LSB. MSB is nothing but most significant bit. It will be always represented in the left side part of the series. Okay, so see the example. This is the binary number system series. This is the binary number. Why? Because these number series having only zeros and ones. Understood? So this is one of the binary number. In this binary number series, the leftmost bit, the leftmost value, right? This is the MSB. This thing only we call MSB. This is the most significant bit. And also this is one of the largest positional weight. This number is the largest positional weight. How it's come, I will explain in the example. You can understand well. Okay. Then next, what is LSB? This is LSB. That is what? The rightmost bit value. Okay. The first right hand side value should be called as what? Least significant bit. That is what? LSB. LSB is nothing but least significant bit, and MSB is nothing but most significant bit. So LSB always consider in the right side part of the first value. Okay, and MSB always consider in the left side part of the first value. Okay, so this is the most significant value, this is the least significant value. So this is the largest positional weight and this is the smallest positional weight in the binary number system. These thing only you can remind that. Okay, yes, now see the example, you can understand well. So this is the example of binary number system. All right, so see the example, the what is the number 1101. This is a binary number series. Understood? And the base value is what? 2. Why we are putting 2? Because this is what? Binary number system. That's why we are putting what? 2. Okay? So easily you can identify it whether it is what number system, whether it is 0 and 1 and base value is 2. Sometimes these number series is based on decimal number system also. Why? Because decimal number system having how many values? 0 to 9, right? So here also 0 to 9 combination number is there. But how can you identify this is whether it is binary or not? The base value. The base value 2 in the sense this is none other value. There is only one binary number value. Okay? Right. Alright, so this binary series we are going to split up right now. So already I told this binary series 1101, the right side 1 should be called as least significant bit. So this is the least or smallest position weight, and this left side value, this 1 is the most significant bit. This is the largest positional value. Okay, so now we are going to see that. See, you just write 1 1 0 1. Is it correct? Yes. The first right hand side value 2 power 0. 2 is nothing but your binary base value and 0 is nothing but that is a position weight. So 2 power 0. In the previous example decimal number system, what we are putting the number here? This is 10. But here this is 2. Why? Because this is a binary. So binary means always 2, right? So 2 power 0. So 1 into 2 power 0, right? Then next, the next value same 2 and position is what? 1, 2 power 1. The 0 into 2 power 1. How its 0 is coming? Because the second series is what? Second number is 0 only, that's what, in the right hand side. Then third one, 1 into 2 power 2. Is it correct? Yes. Then next one, 1 into 2 power 3. That's all. In case one more number is here in the sense, 1 into 2 power 5, sorry 4, it will become like that. Yes? Yeah. Now we are going to simplify. As usual, first you have to simplify the positional value. 2 power 0 means what? Anything over 0, that is 1. And here 2 power 1 is 2. Here 2 power 2 is 4. And here 2 power 3 is 8. You just write that 1 into 2 power 0, that is 1. So that's why I am writing 1 into 1. And here 0 into 2. Then next 1 into 4. How is 4 is coming? 2 power 2, that is what? 4. So 1 into 4. Then here 2 power 3, that is 8. So 1 into 8. Write that. Then again you have to simplify. 1 into 1, that is 1. 0 into 0, that is 0. 0 into 2, it is 0. Then next 1 into 4 is 4 and 1 into 8 is 8. So don't mention 0 here. So that's why I'm not writing the 0 here. So you just write 8, 4 plus 1. So finally you just add all the values. 8 plus 4, 12. 12 plus 1, 13. So 13 is the final answer. Now these binary series are converted into decimal value. So this is the option. One binary value should be converted into decimal value, means this is a step you can follow it. Okay, so this is the binary series value and this is what? Decimal value. So how this binary value should be converted into decimal? These are the steps you can follow it. Okay, then finally it is the binary decimal number. That's why in the base value I am putting what? 10. Understood? Yes. So this is an example of binary to decimal conversion. The given number is binary number. Then we are going to convert that binary number into what number? Decimal number. Clear? Yes? Right. That's all about. Once again I repeat. So binary is a number system having two values. One is 0, another one is 1. Here the numbers in the binary systems are represented to the base 2 and the positional multipliers are the powers of 2. Yes. Number 3, the leftmost bit in the binary number is called MSB, that is most significant bit, and it is the largest positional weight. Yeah, of course. The next one, the rightmost bit is the least significant bit, that is LSB, and is the smallest positional weight, like this. This is a sample. Okay. Yes. And also this is the example. This is the binary number series because the base value is 2. What is another name of base value? That is radix. Already told in the previous class. Base or radix. Both are the same meaning. Okay. Yes. Thank you. The next, octal number system. So what is octal? Octal number system uses the digit is 0 up to 7. You just calculate all the values, totally 8 digits. So the base value of octal number is what? 8. Clear? So 0, 1, 2, 3, 4, 5, 6 and 7. So starting number 0 ends with 7. In between these numbers, any number is coming and along with the base value is 8 means that number series will be called as what? Octal number system. Each octal digit has its own positional value or weight as power of 8. Previous topic, binary means the power value is what? 2. 2 power 0, 2 power 1, like that. So here octal, so the base value is 8. So obviously we are going to use 8 power 0, 8 power 1. That's why the position value should be allotted. Okay, right. So this is a definition about octal number system. And see the example here. This is the number, given number 547. So these series are presented in the origin, right? 0 to 7 combination, right? So 547 number is presented in the 0 to 7 combination, yeah, of course. And the base value is 8. So this is octal number system. Now this octal number system we are going to convert what? Decimal number system. How can you convert this octal number into decimal? The same procedure. You can split out the number 5, 4, 7 like this. 5, here 4, here 7. Correct? Yes. Then of course the first value always you have to take. That is the least positional value. That is what? 8 power 0. This is a octal number, so that's why we are taken 8. 8 power 0. So 7 into 8 power 0 plus the next value is what? 4. So 4 into 8 power 1. This is a next position value. Then third one is 5 into 8 power 2. Correct? And now you can simplify it. 8 power 0 is 1. 8 power 1 is 8. 8 square is nothing but 64. Don't write here 16. 8 into 2 only 16. But this is what? 8 square. So 8 into 8. So totally 64. Okay. So students, don't forget to write the value here. So 7 into 1, that is 7. 4 into 8, that is 32. 5 into 64, that is 320. How does it come? 5 into 64, you can multiply it and you can write 320. Then finally you just add all the values. 320 plus 32 plus 7. Then the final value is what? 359. That is the final answer. So these 359 is the decimal number because the base value is what? 10. So this is a way you can convert one octal number into decimal number. Okay, understood, my dear students? Yes. The next, hexadecimal number system. What does it mean? This is the last type of number system. So a hexadecimal number. Hexa is nothing but 16. Hexadecimal. Hexa, generally what is hexa? It is a 6. Hexa means 6. And decimal means 10. So 10 plus 6, totally 16. Got it? So a hexadecimal number is represented using the base value is what? 16. Yeah, of course. This hexadecimal or hexa numbers are used as a shorthand form of binary sequence. This is the, which one is the shorthand form of binary sequence? That is what? Hexadecimal number. Already we discussed the three different types of number system, right? From decimal, binary, octal. This hexadecimal is slightly different. Slightly, we have a difference. Now feel the difference right now. See that this system is used to represent data more compact manner. How? Because since 16 symbols are used 0 to F. From 0 to F, the notation is called hexadecimal. What does it meaning 0 to F? Already we know the first 10 symbols are what? Decimal number system. Decimal number system. In decimal number system, the first 10 number is what? 0 to 9. The same thing you can follow here also. After 10, you can mention the remaining 6 values like an alphabet. Okay. So first 10 digit is a number 0 to 9. You can calculate even here hexadecimal also, after 10th value, the balance 6 symbols. So 10 plus 6 only 16, right? Already we told this is the base value is what? 16. So totally we have a 16 values. But here 10 value is the same thing, 0 to 9 as usual. So after 10, remaining 6 values you have to consider as a symbol. What symbol? Using alphabets. Using alphabets. So after 10th, after ninth value, number 10 should be represented as A. Then number 11 should be represented as B. Number 12 should be represented as C. Number 13 should be represented as D. And 14 should be represented as E. Then finally, number 15 should be represented as F. So right from 0 ends with F, totally how many values? 16 symbols or 16 values. So that's why we are mentioning here 0 to F. How is it coming, my dear students? Did you understand well? So 0 to 9, the total 10 values same like decimal value. Then after 10th value, you can mention remaining 6 values should be called as alphabets. So number 10 should be represented as 6 symbols like alphabet A. Number 11 should be represented as B. Up to that, number F should be represented as 15. So 0 to F, totally 16 values. This is a number representation in hexadecimal numbers. See the example, then after that you have to get the clear information. See that. So this is the example of hexadecimal number system. So here this is the given number 25. 25 base 16. So this 25 is a hexadecimal number here. Why? Because the base value is what? 16. So how we are going to split up? How we are going to convert this hexadecimal into decimal? The same procedure. You can split out the number 2 and here 5. Always the right hand side value you can take 5 into 16 power 0. Why we are allocating here 16? Because the base value is what? 16. So that's why. So 16 power 0. Then next 5 into 16 power 0 we are entered. The next one 16 power 1. The next position value is 16 power 1. So 2 into 16 power 1. So we have only two combination values. One is 2 and one is 5. So that's why we are mentioning, right, 16 power 0 and 16 power 1. Right? So 5 into 16 power 0. Anything power 0, that is what? 1. Okay. So 5 into 1, that is 5. Then 16 power 1 is 16. So 2 into 16, that is nothing but 32. So 32 plus 5, totally 37. So that is the decimal value of this corresponding hexadecimal number. Understood, my dear students? So these are the different types of number system. I told the explanation and also the examples. So in this video, you just go through all the different types of number system continuously. And in your textbook also, you have a value, you have examples, you just go through it. Then only you can understood well. Then after that, we can do so many calculation part. Then you have to understand more about this number system. Got it? Yes. So see you in the next class along with the same number system conversions. Thank you, all of you.